4 of our recent works, we're going to be doing a demo of them. Just to quickly put into perspective for about a minute, just see if this is working. No. 1 second. So our organization is called Sanskrit Research Institute. It's based in Oroville, near to Pondicherry, about 12 kilometers north of Pondicherry. And I'm a graduate research student with ANU, Australian National University. And the institute's part of Oroville. So it's an Indian institute. And I direct it, which is a lot of fun. And that's where we are. And this is our team. And team is international, on and off campus, voluntary, and interns, and some permanent like myself. I'm not going to go back on, I'm only going to focus on 4 of the newer works that we've done, but just to recap is that we've worked with educational tools and some research tools with Sanskrit. We did a dictionary, took a whole lot of, it's a meta dictionary, took data from many different sources. It was an aid for tertiary students and also secondary, like late secondary students. It's quite popular, and we keep modifying and improving it. It has its quirks like anything, but it's getting there. And then we've done comparative grammars between Vedic and classical. It was really like just seeing the gap where things were missing, and then not to duplicate things that have already been done really well. And we've made some educational games, and we've done some things that have already been done before much better. So like Sandhi tools, and one thing that I quite like and used is we made a typing tool for touch typing Sanskrit. It uses its own system, but the idea was to basically use the neural maps you have in your brain without teaching something new. And it seems to be quite popular with people who haven't learned an existing system already. So I'm going to talk about some of our recent works, basically, that, and we've shared them already on Indology and with the scholarly community. And I'll dig in a bit of technical detail where needed, and obviously in the question time, you can hit me with the technical questions. So number 1 was I surveyed to see if there was a word frequency tool for Sanskrit, and I couldn't find anything that had been published and available. Oliver Helvig from the DCS had done elements, but he hadn't completed it. So we wrote some scripts in Python, and we extracted the snapshot of the DCS, which is in the public domain. That was 3.2 million words at the time, which was single-handedly done by one person. It's quite I think he deserves some kind of award if we have an award in the conference. Actually, it's up to 4-point-something million. So I don't know if he sleeps or not. So we extracted it, and then we took the data, and then we made different intuitive ways of looking at it. And this is the live demo. And so you'll see there's 3.2 million words with 67 unique words. What's defined as a word will basically be a stem and a prefix, a stem and a root for a verb, and oh, must I make it bigger? That's as big as my screen will get. Maybe I can go F11. That'll go 1 step bigger. That's about as, I can't do more than F11. Is it legible? Yeah. No. Well, I'll send you the slides, and I'm sorry about that. I think it's the DPI of the projector. So we try to. The objective here was basically to firstly accomplish the task of doing this, and we had to use data from somewhere, and DCS is the best data. It has limitations, but it gives you quite useful data for comparative frequencies. We've got a Ukrainian scholar now doing a comparison between frequencies in other languages with this data. And you can filter it down based on tagging that we tag the literature, the corpus that we use. So you could just say in Vedic, and it changes a lot. Things like Agni and Soma Marut will obviously come right up to the top of the pops in the Vedic, but they will lose after the late Vedic. They will start to be. And you can look at the Buddhist literature, and then things like Buddha will obviously come top of the pops. And yeah, there will be gray areas, of course. But it's not. You can't be very specific, because a Buddhist era is not something you can measure with a piece of string, but you can generalize about the literature from that era. And you can also search it. If we reset you can search for a word if there's a word you have a fascination with, you can search for the frequency. And we've got some kind of graphing over time, but this is in beta, so I do not, you can see there's an error. So it is in beta, but it can be useful. And we put it out there, and it's being used. And then you can also filter by a specific text. Now, obviously, he hasn't done all the text. You'll see there's a star if the text is incomplete, and it's not starred if it's complete, because Oliver only did the things that were of interest to him. Now, at the end of my presentation, I'll talk about our Moonshot project, which is called Sanskrit Archive, and that will have a lot more than 3.2 million words. That's going to have hundreds of millions of words. So obviously, this will get more accurate, but 3.2 million is not a bad starting point. And it is on our cards to refresh it with the latest DCS data, but it's a lot of work. It's going to be like quite a lot of man-hours, so we haven't got around to doing it yet. But it's on the cards, in case you're wondering. And you can filter by author, by subject, and you can also filter by part of speech, POS, if you want, basically, based on how the data was tagged. So we just say noun, we don't go into the case, basically, at all. So yeah, it's out there, and you can play with it. Probably a few of you already know about it, and if you don't, please go and give us some feedback. And the second one we did, which was also a gap. Now, Oliver, once again, had already done this, but he had made a Windows desktop tool that couldn't operate in an automated way. Now, the bigger project that I'm working on needs an automated OCR engine. So initially, I tried to automate a Windows tool running through a script and sending data in and out, and it was just kludging it, clonking and kludging. It wasn't working, basically. Is it a kludge in programming when you don't get things to work? And so what we did is we worked with Tesseract, and with Google got a very nice API. And I collaborated with Ashok Popat, giving him a feedback loop on Sanskrit-specific errors in their engine. So I thought rather let a company like Google throw lots of resources at solving this problem, because OCR, computer vision, is really complicated, and you need massive resources to do it very accurately. So it's got up to a level where I would say it's above human, it's close to human, close to a very high-level human accuracy. And it's definitely faster. And let's demonstrate it quickly. So what's nice about it is it works with the clipboard in the browser. So I'm just going to paste some, there was some Sanskrit in my clipboard. There it is. So this is just a photograph or scan at quite a low DPI. And you can check it for errors. I'll reward anyone who finds an error. Okay, there might be an error there. Okay. Pretty accurate, which everyone agrees. So this is browser-based. It's got Tesseract and the Google Vision API together, and then we're working with Google AI team to, if scholars report errors, we basically feed it back directly to Google, and then they improve it, hopefully. It's not always an instant fix like if it was Tesseract. Tesseract was originally pretty accurate, but much slower, because it uses a lot of resources to process. And now Google's just gotten so good. So this is being actively used by a lot of the digitization communities, and we're going to be upgrading it. I know that a lot of people wanted it to do documents. It's a mixture of two. It's Tesseract and Google running in parallel, basically. It runs on Node.js for those who want to get geeky about it. Okay, so this was the second recent project. We also announced it on Indology, and it's been relatively well engaged by the Sanskrit community. And it does IAST, and it does Devanagari. And it understands Sanskrit as a language, not just as a script, not just Devanagari as a script. So it understands context and edges and all the things it needs to, and keeps improving. This is the nice thing about using cloud technology, is you don't have to upgrade it. This was a reference in my 5th year at ANU. I was reading Panini. People thought I was a bit nuts, but it was fun, and it's really complex stuff. So I made like a programmer's reference because it's very programmatic. Should we keep the questions for after, or do you want to interrupt the discourse, and then should we let it flow, and then we just write your questions down, and then I'll do them in reverse order, or first in, first out. Okay, so this is PERT, or Panini Research Tool. Now, at the Bangkok conference, there was that lovely Panini 2.0, and I was very inspired, and I didn't want to duplicate what they did, so it's similar, it's got some overlap, but then what we did is I got permission from the copyright holders, from Vasu, basically. You'll see that this is the, so we've got, okay, so Valentine was there out of copyright. We digitized that. We've got a team of volunteers that are pretty good at doing sort of, well, we didn't digitize it, we just snippeted it into small bite-sized image. It hasn't been fully digitized yet. But where we could digitize, we did digitize. And then we took some from the Ashtadhyayi 2.0 project, that was a little bit. And then from Ramanath Sharma, we've also got permission to use his work, which is phenomenal work, for some of his work. And we had taken from many different sources. We also got audio recordings, because the sounding of this literature was very important in the tradition. So I'm not sure if the audio is connected. Well, let's try that. But you know, for what it's worth, you've got the full. Okay, speaker out. It's got a bit of feedback there. Oh, buzz. I don't think it's coming through the system. I think it's not connected. But you just have to believe me that it does chant quite well, everything. And it's just a consolidated reference with a search. Now, when you're studying Panini, the search is really, really useful. So you can search, you know, ad infinitum, and then it understands to look through the translations and the definitions. And it was very useful for myself, and now I think a lot of other tertiary students are using it. If anyone has suggestions for improvements, I'm very, very open ears. And we were happy with this. This was also relatively recent work. And then the DLI, Digital Library of India, the reason we did this, it's okay, I think we'll skip the audio. It's totally fine, it's totally fine. I'll simulate it. The reason we did the DLI was the government site didn't go deeply into the documents. So once again, we worked with Cloud Vision. We threw everything onto the Google servers, and then we've got a collaboration also with Google for storage. So it's 31 point something terabytes, which would cost a fortune normally to store. So we threw that onto the cloud, and then we just wrote some smart scripts that are using the Google Cloud Vision to understand this. And it allows you to do quite deep searches. Now, DLI is a very, very useful, and in our bigger project, there's a lot of info we're going to cross-reference to. I wanted to just have this, that it was available in an accessible way. So this is all, I'll do the demo for you in a second. It's a DLI mirror. Now, archived.org is partially done one, and then the government one is up and down, and then it's in transformation. So it's going through different evolutions, as far as I know. So it wasn't that reliable. It went through like a long period of unreliability. So yeah, you don't even need to spell it correctly, because it will intuit for the diacritics, and it should be quite fast. Now, we're searching 31 terabytes of data in about 4 seconds, and probably it would be 2 seconds if I wasn't running through my mobile. And then, of course, you've got everything there, all the PDFs, and you can do what you want with them. And then we've got all the metadata and the bibliographical info. And this is also being used. I think some people use this and the government one and the archive. There's different advantages, but it was something that I wanted to have. It's got all of the, in theory, all of the out-of-copyright books that have been digitized. Not all, but a large percent. It's kind of like a mini Google Books of academia and institutions in India. And it's got some phenomenal, if you're looking for something really random, like a needle in a haystack. So with the cloud search, that needle in the haystack, that's the whole thing that the cloud search is good at. It's good at finding needles in a haystack. And so it was like a no-brainer to do this, and we did it. And once again, shared it with Indology, and people seem to be using it, which makes us happy. And then, okay. So this I actually presented in Bangkok. We're busy revising it now. It's our text-to-speech engine. And we're going to make it as an API that anyone can just call. we took Mary TTS, with a German AI Institute engine for text-to-speech, and then it works well for single words, and in theory for sentences. It can work. We just didn't focus on sentences because it was an individual word approach. I can't demo it, but it's working. You can all go on our dictionary sites and see it. So we're busy doing that as an API that will be a public API. It will also be put on one of the cloud services, and then people can have audible Sanskrit wherever they want, and that can be useful, especially considering Sanskrit was not a written language until recent history. About 2,000 years it's only been written down. For the older history it wasn't written. So our Moonshot we're working on, this is a collaboration with Wikimedia Foundation that we're beginning because it overlaps with some of their objectives, and they obviously have very deep pockets and great skills and abilities. And I met with their team in Cape Town. They had a Wikimedia conference. So we want to put the extant Sanskrit literature online. It's a moving target because as I speak this presentation, some literature has been decayed and destroyed somewhere. It's like global warming, like you talk about it, and we already gotten warmer. So, but we're going to do it with two. Okay, so how much literature is there? Well, some people say this was from Sheldon Pollock's estimate was 30 million manuscripts. That's a huge number, and it's his reference, not mine. Otherwise, it would sound like way too much. It's in language of the gods, if anyone wants to see it. So what's happened is Latin and Greek have had it done. You've got TLL and TLG, and they've done almost all the extant literature. And that's your classics, for European classics, and hasn't been done for Sanskrit. And I really appeal that we should all work together, and all these tools should make this happen. That in the next, say, decade or 5 years, we can have extant Sanskrit literature in digital form online. So I see it as quite an insolvable problem without two things. So it needs crowdsourcing. There's no way you can do it as an individual effort. Even if Oliver Helvig lived 1,000 years, it would not happen. And we've got to use neural networks, convolutional neural networks. So what we can do with the AI is we can do automatic breaking of the sandhi, and I think we can get up to 99%. We can do automatic parsing of the data and grammatical tagging and get to very high accuracy. We can do automatic sense disambiguation and also get very accurate, and we can definitely do translation. So with a convolutional neural network, as we have more data, it's going to get more accurate, and eventually it's going to be so accurate that you're not going to notice it anymore. So this is a Moonshot. We're busy working on it. We've got some. It's a parallel work in operation. We should have something to present at the next. When's the next conference? In 3 years. So I should be able to present something at the next conference on that project. And that's my email. If anyone wants to reach me, we've got come to the end of the demo. Thank you very much.
Thanks, Martin, for this very wonderful demo. Questions for Martin?
Easy ones, please.
Thank you. Two questions. So, do you have any thoughts on providing an API for Google Vision OCR? So I
Yeah.
have no experience setting up.
We can do that.
My Google Cloud account recently
Yeah.
expired. And
Yeah.
I have a more stable.
I think we could do that. If you send an email, I think we could put it in the pipeline. Sure. There's no reason why we can't do that. It wouldn't be like a public. I mean, it would be free of charge, but it would be basically on an invitation basis. But yeah, we could do that for you. Sure. There's I see no technical reason why it's not feasible. But yeah, we just don't want the whole world doing it, because then the resources would get stretched, and Google's generosity to us would also be challenged. So we want to use it specifically for. So yeah, sure, we can do that with pleasure. Oh yeah, sure.
When it comes to the CNN models that you're going to use for segmentation,
Yeah.
do you imagine using domain-specific, so models trained for a particular subprogram? To very high accuracy, then you're going to need to
Yes.
specialize, not use
Yes.
one.
We would model what's already been done successfully with languages like English. I mean, like English has got so much data. So Sanskrit's just another language. It's got nuances like Sandhi that English doesn't have. But we would use whatever, it's a moving, because it's constantly improving with Moore's law and so much research happening with AI. There was just a publication of DeepMind basically doing the Greek manuscripts with missing letters where there was total, much more accurate than humans now. So I think with crowdsourcing and AI, our archive project, it's the only way to achieve it. There's no other way. Like Elon Musk said, like, if you want to get to Mars, you've got to have reusable rockets. There's no other way. So it's the same. Like, for me, because my background is from computer science to Sanskrit, I can't see any other way to easily solve that problem. And I do see it as a solvable problem, just a difficult problem. It's difficult because the data's got a high noise to signal ratio. There's a lot of, you know, a lot of issues with data. And then also, well, there's a limited pool of scholars who can give a high quality curating of and tagging, and you know, you can get a lot of people who say they know Sanskrit, but to the level that you want to do it, on say Oliver's level of tagging. But we've got a way of incentivizing people. That's in the pipeline for the project. So let's see how it goes. Sure. Any more questions? I mean, well, how much more data do we need to do it? I think maybe 10 times more than is currently available. No, you're talking about for parsing. Maybe, yeah, the more data you have, the better. So I don't know. I can't estimate until we've started that project. But the more data, the better. I don't know. Maybe you could guess. Yes. I don't know, actually, at the moment. I don't know. No, the DCS data is like 3.2 million words. So, yeah. It's possible to build a rudimentary system that is maybe 80% accurate. I think so, yes. That's my estimate. No, but we're going to have a lot of data. That's the whole idea, is to have the data. Yes. Yeah. Yeah, 30 million manuscripts. No, it's not. No, it's not going to be manually tagged. It's going to be assisted tag. That means humans will be involved, but the tools will speed up the process, basically. Just like Wikipedia. I don't know at the moment how much data, because we haven't done that part of the project. We're doing the formative phase. That will. I mean, I can tell you for like the frequency. The data is useful, but I can't speak about unknowns that we haven't done it yet. It's just hypothetical. Maybe Oliver Helvig could give a more accurate estimate, because he's the best with that. But I mean, so maybe if you have like the DCS, it's a very good starting point, basically. But it's not tagged to the detail that we're going to have our data tagged to. Like Peter Scharf's tagging is much more detailed. Oliver's tagging is just suited for his particular need with DCS, basically. No, so I think the Sanskrit library was more detailed, like the samasas were what type of compound, and then Oliver doesn't care about what type, he just says compound. He doesn't say what type of compound. So Peter Scharf goes into it's like the gold standard. So I would use a standard like that for the tagging, because that level of detail is very useful linguistically to understand meaning and context. The type of compound can make or break the meaning, in the Vedic or the classical. I'm sorry about the questions I can't answer about the amount of data, because yeah, sure. But it's possible. Do you think? Yeah. Okay. Next question.
Any more questions? Okay, so let's thank again,
Thank
Martin.
you.